Hi guys, this is Coach Zane, and in this video I'm going to be explaining the basics of programming in FTC. Now this is going to be a longer video series where we cover how to program in both blocks and Java, so there'll be separate lists of videos for both of those types of programming. But this video is going to be the common one between both of those, because before we can actually start programming in blocks or Java, we need to understand the control system of FTC. So with any kind of robot, well, in order to program, we need to first understand how to control it. So we have this machine or a set of mechanisms that work together. So you can think about like a car or even something simple like a washing machine. In order to program that to follow a set of actions, we need to understand how to control it. And this is no different to FTC, because in FTC we're given a set of tools and we build around those tools in order to create a functional robot. And so we need to know how those tools interact with each other and basically connect to then program. So first things first, we need to understand the kind of elements that go into an FTC robot. So assume we have a robot, which is represented by this icon over here. Now, this robot is made up of a few key components that will ultimately slap together to create a robot. But for the sake of programming, we don't really care about any of those mechanical components. We don't care about the screws or the metal or the mechanisms. We simply care that there is a functional robot, like a thing. Now, on that robot, there are a few important things that make it a robot that we can program. The single most important thing that's relevant to a programmer is the control hub. Now, the control hub is this kind of device over here, and this device has a lot of ports that you can connect things into. So you can connect motors, servos, sensors. You can also connect a battery to it, and you can do a lot of things with this control hub. This is effectively the brain. So if you've done FLO in the past, this is like the Spike Prime hub. And we basically have to put this on the robot in order to program it. Now, that's great and all. So we have a control hub, and you might think, great, we have a control hub, that's it. We just use a laptop to program the control hub and it'll do what we want to do. But that's not really the end of the story in FTC, because in FTC, we need to program the robot in two different ways. The first way is the most common and, the more intuitive way, which is we set a bunch of commands to the robot. We press play somewhere, maybe on the laptop or somewhere else, and it'll go and do its thing. That's fine and all, but we also control the robot in a second way, which is using remote controls. So we have these gamepads over here. You can use PS4 controllers, Xbox, or Logitech controllers. And for 2 minutes of the FTC game, you have to then drive the robot around physically with a remote control, kind of like a remote control car. Now, the catch to this is that you need to do all the programming for both of these two different ways using your robot and what you have available to you. Now, this all of a sudden makes things more complicated because we need a robot, which is what we already have, this icon over here, but we also need a driver station or a driver hub. Now, a driver hub is separate to the robot. It's its own Android device. It's kind of like a really small phone, but it's well put together and it's pretty solid. You can actually use an Android phone instead of driver hub, but most teams nowadays are going to use a driver hub that you see right here. And connected to this driver hub are controllers. So they have USB-A ports where you can plug in controllers using micro USB to USB-A connectors. And pretty much you'll then program those controllers to talk to the robot. Now, that's a little bit complicated because we mentioned a lot of things, but to simplify it, we have a robot. On that robot, we have a control hub, that's the brain. That's done. We have that system set. The builders design it and give it to us. We then have a driver station, which is completely separate. It's not connected to the control hub physically, but it will connect somehow. We'll explain that connection a little bit later. We have controllers that connect to the driver hub. That's all good. And now the final piece of the puzzle of this triangle is a laptop. Now, a laptop is pretty important. It's used to write the code that will then be deployed onto the control hub, not the driver hub. So the laptop talks directly to the control hub on the robot. Now, let's talk about that connection a little bit more in depth because that overview is too simple. So the connections. First things first, the control hub, that's the middleman, really, not the driver hub. So the control hub is in the center of the story, the robot's the main thing. When the control hub is turned on, it will flash a green light, which means it's ready, and it will basically emit a Wi-Fi connection. So it's basically like your modem in your house, right? The internet box thing that emits a Wi-Fi network. Your devices then connect onto that, and so you have Wi-Fi. Now, the control hub emits Wi-Fi, but this isn't the internet, right? The internet is used to then connect to websites, and you can use Google to search things up. That's not what this is. This is a Wi-Fi network that emits, the control hub system. So when you then connect to the Wi-Fi network using the driver hub, you can play programs. It's pretty simple in practice because the Wi-Fi network is relatively stable. You turn on the control hub, it has a built-in Wi-Fi network. You don't have to program the Wi-Fi network, it just works. The driver hub is an Android device, like we said. So you go into the settings just like you would in any other phone. You click the Wi-Fi network of your control hub. Don't click anyone else's because you don't want to connect to anyone else's robot. And then you type in the password, make it secure so that your robot can't be, hooked onto by anyone else. And then you can play programs through an app on the driver hub. So this is called the driver station app. It's already inbuilt onto most of the driver hubs. So when you purchase it, it should have it already there. You might need to set up a few of the settings, but I'll go through that in a next video. Now, that's pretty much all good. After that's done, you have a driver station. So you have the thing that will play programs separate, and then you have your robot separate. This is pretty good because now when we step onto an FTC field, you put your robot on the mat and then you step outside of the walls and you play your program separately. So that's pretty much the control system in a nutshell. It's these two things that work together. But the last element, like we said, is your programming device or your laptop. So you pull up a laptop and you open up the relevant programming software you want to use. So if you want to use Java, you can use that. If you want to use blocks, you can use that. Again, I'll explain how to use both of those in future videos, but for now, let's just assume you have a laptop with everything working. In order to deploy code, or in order to send code, let's let the screen focus. In order to send code onto your robot, you have two methods. You can either connect onto the Wi-Fi network of the robot, and that's pretty simple. You just basically open up your settings in Wi-Fi, just like you'd connect to any other Wi-Fi network. You'd type in the password again, and then you'd see that whatever programming method you're using can pick up the robot. And then you just save code or build code, depending on if you're in blocks or Java. And then basically you'll see all of those changes happen on the driver hub, right? Instantly. It's pretty seamless when it uploads. It takes a bit of time if you're using Wi-Fi, but that's a completely wireless connection. You don't have any wires from any of these three things connecting them. That's pretty good. Now, the second way is to use a wire. A wire is faster and more reliable, but you're not wireless. So basically you connect a USB-A to USB-C wire or USB-C to C from your laptop to the control hub. So from these two things here. In order to make that happen, you just need to have the wire ready. And again, when you press upload code, it'll send your code from your laptop to your robot. So again, just to explain this, three things together, you have your laptop, which speaks to the robot, and more specifically, the control hub on the robot. That then relays all of those changes to the driver station. The driver station is just more of a controller. You can play programs, you can stop programs, you can connect your gamepads to them to run the code that you want to run. And yeah, that's pretty much an overview of the control system. It's relatively straightforward once everything's in practice, but this video is pretty much just there to help you understand these three things and how they connect together. Now, two more important things. The first one, we need to understand that a robot isn't just a fixed machine that the design and builders will give to you, and it will just work. There are going to be, problems that you need to fix. You may need to fine tune and debug things. Overall, it's going to be a bit of a challenge to program your robot at the start. And it's good to understand what goes into your control hub. So this is a diagram. It might seem a little bit intimidating, but pretty much connected to your control hub is going to be most likely an expansion hub. So if you want to use more than 4 motors on a robot, you need to use this separate board. It's basically a control hub, but it's just an extension on it. It's kind of like plugging in a power board to your, socket, so that you can get 4 extra power board connectors compared to your single 2 sockets. So connected to that control hub and your expansion hub will be your motors, which are these things over here. These are pretty powerful actuators to turn your wheels or your elevators or your arms on the robot. So that's done. You will then have servos. These are little smaller, not as strong actuators, but they can open claws or rotate things separately, open latches, close gates, that kind of thing. You'll then have sensors. So the main sensor you have is probably a camera, hopefully, or 2 cameras, and that connects to your control hub using the USB ports. You'll also have some sensors like your color sensors. You might have some limit switches. And finally, you have a battery. And connected to the battery will be a power switch, so you can turn on and off your robot. And so when you're delivered a robot, it will look like this. But, underneath the surface, there are all of these electronics that go into the software, and they go into the system. And so as a programmer, it's your job to make sure you understand all of the electronics, make sure that they're wired correctly, and understand their functionality, at least on a base level, so that you can program them properly. And you can ensure that there's adequate control so that when a driver goes and presses play on your program, it's going to control and act as expected. So that's pretty much this video. The last thing is a caveat, which is this video is only relevant up until 2027, because in 2027 there's going to be a completely new control system, and so pretty much all of this information is going to be not outdated, because you can still use the control hub for a couple of years, but eventually the system will move on and we'll have another system that comes into play, because as you come to understand, the system isn't perfect. It works, but it does have bugs in it, and it's not as powerful as it could be. So yeah, that's pretty much this video. In the next video, we'll be explaining how to actually set up your software and run some basic code.